So this is basically a short demo for analyzing a large file with Pthreads and C++ language. So this is the large file we are going to analyze. This is about 3.1 gigabytes. I can show you in one of the codes that we are going to analyze this file. This is where we are basically sending the file name or the input file name over here. As you can see, to reconfirm, this is a 3.1 gigabytes file. We will analyze this file in the question number 1 and question number 1b. We will figure out the total number of words, the vowels, as well as the top 10 words in each case. First of all, I will run the first file with 8 threads. Now, obviously, the execution time shared in the report is going to be a bit different from this. There might be a few reasons behind it. Right now, I am using screen recording to record this demo. So there might be a little bit effect on the CPU utilization. So it might take some longer time. We are waiting for the result. It is taking a bit longer as compared to the execution time given in the report, because obviously right now we have a lot of processes running in the background. We have a meet going on, we have the share the screen going on, we have the camera on, so it has to obviously context switch a lot. So that's why it's taking a bit longer as compared to when I use the execution time. So it is taking 49.8645 seconds, but the output is exactly as same as mentioned in the report. So why did it take a bit longer time? It was obviously because we are running more processes on the background as well. So that's why it took a longer time. We made 8 threads. That's why it took 49.8645 seconds. If we had 4 threads, it would have taken longer. If we had 2 threads, it would have taken even more longer, because obviously the 8 threads are dividing the piece of that text file a into different chunks. Now we can run the second question. Now this question uses affinity. This should try to improve the execution time. It may or may not improve it. So we are again using 8 threads just for like the confirmation. I'm only going to run the 8 threads demo over here. Again, this is going to take a bit longer as compared to normal conditions, because obviously there are many processes running in the background. You have a whole Chrome browser running, it is sharing the screen, it is recording, and the meeting is going on, and we have this code file running. So that's why it's going to take a bit longer as compared to the execution times normal. Yes. So now this has given the exact same output as this over here. It did take 3 to 2 seconds more, but obviously, as you know, there are different conditions, so that's why this has taken a bit more longer, maybe 3 seconds more. But in most of the cases, this code, which has affinity in it, will obviously run better as compared to this. So now we are going to use the task number 3. So there are 2 tasks that I have done: the task number 2 and the task number 3. In task number 3 now we have to figure out the word with the most frequencies, and this will write to a file. I will show you the file as well. So 8 threads again. Obviously, this is again going to take a bit longer as compared to the report time. So till this time that we are giving you a demo of this, let me show you as to why this 3 GB file, it's been accessed very nicely, and apparently it's giving you a result very quickly. Because it's a 3 GB file, this might take a bit longer on the internet and everything. So we are using basically the concept of parallelism. So what we are doing, we are basically doing multi-threading. So The file which is given to us, or the data set, is basically a 3 gigabytes data set. This is basically broken down into chunks depending upon the different threads. So right now I have 8 threads. This 8 threads will basically divide this file into different chunks. Once it divides this into different chunks, those chunks will execute this all the functions given in the program one by one. For that, we have mutexes. Now, the question arises, why are we using mutexes? We have already threads. The reason we're using mutexes is because we need synchronization. So, for some reason, if I had not using synchronization techniques over here, this code result over here and over here would have always changed, because in some cases, one thread would have accessed the word count earlier than the thread which was supposed to. So right now I ran this case for you, and as you can see, it shows you that your result has been saved to the output results affinity and has given you 51.4931. Again, I'm repeating myself time after time. The reason is because, as we know, as we know that we are basically running the recording as well. That's why it's taking a lot of time. This is the file it is given us. It is sorted by occurrence. So obviously this is the file which is given us. Now we have to run the last code. Okay, this executable C was basically the one with affinity. Now we are going to run the one without affinity. In some cases, this will give you a time lesser than the affinity one, and in some cases, it will give time greater than affinity one. But in most of the cases, you have to remember that affinity will improve the execution time of the code. All details about affinity and how it has been applied have been given in the report. We are again going to wait for this. So just not to waste our time, we are going to again look at this. So we're using mutexes. The use of mutexes, as I was explaining, is basically to synchronize my code. So what does it do? So you have got 8 threads. One thread now goes up to a function. It has basically a chunk of a file. What it wants to do is that it wants to save that word in the total word count. But what if another thread comes in and it says, okay, now I want to access this word? How does the program recognize that I have already counted this word, or just for the sake that the first thread gets the first priority? That is done through synchronization, so that the thread is not disturbed. We have already got a result, and as I told you that due to affinity, that we have, this is without affinity, so it has given you a result faster than this one. But this obviously is not always the case. So we have got another file over here. Let's check out that file, and this is the file which it has given us. And as you can see, it has given you a correct output in most of the cases. So this is the output is being correct, everything is right. So this is the demo part of this assignment. I will record another part in which I will explain how the code works and how is it dividing in the file into different chunks. I have just given a brief overview in this video as well. Thank you.